Okay, Portable for parents and students, I just want to go over what is on the test tomorrow. Right now it's Sunday morning. I've given this already to all the students, so they should have that in their agendas. But just to go over, it's mostly the first half of Chapter 2 in grade 5. These are the sections that they need to know, and it kind of covers writing numbers in words in expanded form. Expanded form means 23 would be 20 plus 3, for example. Greater than, less than, and some rounding numbers. And it goes all the way up to the mid-chapter review. In grade 6, it's kind of similar, but they have another section called renaming numbers, which was a little problematic. So I'll talk a little bit right now about what that means. As well, on the test, there will be a 10 by 10 multiplication chart for the grade 5s and a 12 by 12 multiplication chart for the grade 6s. What I'll do is I'll give them a chart and I'll put little spots. Maybe they'll fill in about 10 different facts on the test. Because we talked a lot about decimals in this section, I showed them this decimal diagram, which I got from the internet. And you can see that stuff to the right of the decimal is kind of mirrored in what you see on the left, with one exception. But for example, there's tens and tenths, hundreds and hundreds, etc., etc. But you've got ones on this section, you've got no ones on this section, one-th, for example. So it's kind of mirrored except for the ones there. And we also did a bunch of multiplication word problems, and I showed the students 6 different ways in theory that you can different strategies you can use to solve a multiplication problem. Of course, you can use multiplication, but many students didn't have a clear idea about what was happening. So I showed them these 6 different strategies and what that might look like in a simple problem. Let's say you have a simple problem of Mr. Macaulay plants 4 flowers every day. How many plants, how many plants does he have after 3 days? Well, that's not the numbers on, pardon me, on the test, the numbers will be a little bit more difficult, but let's just work with that just to illustrate. So one thing you could do is you could draw a picture. So every day I do 4 plants, so 4 by 3 days, and that'll give me an answer of 12. Here's another way is make a table. So here's the days. Day 1, I have 4, and day 2, I have 8. Day 3, I have 12. So that's another way of solving it. The other thing is you could do is repeated addition, because multiplication is repeated addition. 4 plus 4 plus 4. Every day I do 4. If the elements were scattered, then you could group them into groups of 4. That's what grouping is. You could also do kind of skip counting. So it'd be 4, 8, 12. And finally, another strategy is to build an array. Array is kind of like a fancy table, a grid, where you do something like this. And it's very similar to draw a picture, if you can see. But these are 6 different ways that you could potentially solve a problem. We did a number of problems this way, and I will give them a problem and ask them to solve it 1 or 2 ways using one of these 6 strategies. Okay, this is for the grade 6s now. The grade 6s, they talked about renaming numbers. So let's say we look at 2,400,000. Another way of writing that, of course, is 2.4 million. But another way of writing that might be 2,400 thousands. So 2,400 thousands, kind of a little confusing. I did show them how to use a chart like this when you have a number to fill it in on the chart, and that kind of gives you an idea about which numbers go where. I made a little video explaining how you would work with this, and it's going to follow right now. Okay, I want to explain how to do this type of question. In this type of question, it's asking what's the difference between 2.4 million and 1,600,000 thousands. Let's deal with one at a time. 2.4 million. We have our little chart here for millions and thousands and ones to help us to organize this number. 2.4 million, 2.4, the decimal. So the decimal would typically go here between, because we're starting to talk about millions. If I was writing 2.4 millions, I'd write 2.4 millions. So I can add lots of zeros on this side. 2.4 million. Really, it's 2,400,000 is another way of saying it. But now I've got this problematic number here where it says 1,600 thousands. Because I'm talking about thousands now, this time the number is going to start, I'm going to put a decimal here because I'm talking about thousands, and this is where the thousands begin. 1 1,600 thousands. So if I think about it, 1, 2, 3, 4, 1,600 thousands. And again, I can add zeros. So now that I've organized the chart, I want to try to compare the two numbers in a way where they're both using the same unit. They were talking about numbers in terms of groups of 1,000,000, and here they were talking about numbers in groups of 1,000. In order to compare them, it's a lot easier if they're in the same kind of unit. So the unit I usually choose is just plain old ones. Or I can also do millions too. We almost never really do thousands though. If I want to do millions, I could compare this by using decimal here and saying 2.4 million compared to 1.6 million. Or if I want to do ones, I would turn these into commas, and it would be 2,400,000, and I'm comparing that to 1,600,000. So what's the difference? This time, to make it easy, I'm going to work on the millions. So I'm going to say 2.4 million. And the difference, so difference is always a takeaway. It's always a subtraction. I put the larger one on top, 2.4. Take away 1.6 million. Now 4 take away 6, I can't do that, so I'm going to carry. And 14 take away 6 is 8, and 1 take away 1 is 0. So that is, the decimal just flows right down here. This becomes 0. So it's 0.8 million. The difference between 2.4 million and 1,600,000 thousands is 0.8 million. So just to recap, when I'm doing a question like this, I want to make sure that I organize the numbers in the chart so that it makes sense. They're in the right spot. And then when I finally want to compare them, I try to make sure and use just one unit, the same unit. So I could have used ones here. I could have put I could have also done this. Take away 1,600,000, and I would have got the number of 800,000. So that's correct. And I also could have done it the way I did it here. If you do it this way, make sure you add the millions over here. Otherwise, you just say it's 0.8. I might not know what you're talking about. Anyways, this is how you do this type of question. And it's a question that a lot of my grade 6s had difficulty with, mainly because the idea of 1,000 thousands was difficult. But here's my hint, 1,000 thousands is 1,000,000. So whenever you're talking about 1,000 thousands, right away you can think about it in respect to 1,000,000. Anyways, I hope that helps, and good luck with your test.